Alright, so now we know something about similar right triangles that are formed when we've got an altitude cutting down the middle of a right triangle. And we know that we can set up proportions based on ratios of the legs. Well, here we're actually going to get into solving for certain side lengths using those certain proportions. Okay, so we've got the roof of a house. That's a goofy looking roof, but it'll work for our purposes as we're practicing this. And we're going to first identify the similar triangles here. So when it says we're going to identify the similar triangles, what we're really saying is let's set up a similarity statement. So I'm going to have three triangles, and I want them to be similar to the next one. Okay, so now I've just got to fill in the names of those triangles. I'll start with the largest triangle. It doesn't really matter what you name the first one. Let's call it ZYX. So I will put that in here, ZYX. Now if I go to the medium triangle, this is the triangle that I want to identify, but I can't just call it ZYW or ZWY or YWZ without any thought. I have to think through how it compares to that larger triangle. The larger triangle, I started with ZY. Okay, ZY in the larger triangle was the longest leg of that triangle. Okay, so I want to match up my first two the first two letters of my medium triangle as the longest leg. Okay, so the longest leg in that side is going to be ZW. Okay, ZW. But I could also call it WZ, and that's important here too. So again, going back to ZY, ZY was the longest leg of that large triangle, but it was going from the hypotenuse side and connecting to this side down here, which is off the short leg. So I want to do that in the same way in my shorter triangle. When I'm looking at ZW, I'm going from Z, which is near the hypotenuse, and going to the short leg. Okay, so I will call this ZW. And then obviously the last letter there has to be Y. So that's kind of the process that I'd want to use to think through how I'm labeling these different triangles. If I do that same thing with the third and smallest triangle, again, I want to start by comparing to ZY, which is the longest leg, right there. And I want to go from the hypotenuse side, Y, down to the short side, which is W. Okay, so the first two letters of this smallest triangle I would call YW, and then obviously the only thing left to help name that triangle is X. Okay, so when we're identifying the similar triangles, that's what we're looking to do, come up with a similarity statement that shows how these triangles compare. Now that's important because it's going to help us identify different side lengths that compare with one another as we start setting up proportions. For example, I know that ZY compares to ZW in the same way that YX compares to WY. Okay, if I've got it written out already in a similarity statement, that's going to make things a lot quicker, a lot easier for me as I'm setting up these proportions. Okay, so now let's find the height of the roof. The height of the roof, which is labeled as H, is this segment here. That's the one that we want. Now, going back to some of these things that we talked about before, when we looked at setting up proportions kind of like this, we always had labels on the side and labels up above to show us what two triangles we were comparing and which parts of those two triangles. So we're going to do the same thing here, but I'm going to suggest that before you do that, you ask yourself this question and maybe even write out the answer to this. What sides do I know about? Okay, because you're not always going to be given every single piece of information. So in the small triangle, and in the medium triangle and in the large triangle, you're going to have certain sides that you know about and certain sides that you don't. So let's take a look at what we do and don't have here. If I'm looking and keying in on just this smallest triangle, I have a value given for the hypotenuse. I know it's not a specific value, but we've got a variable that we're trying to solve for here, H, as the long leg. What I don't have here is the short leg. WX is not a value that has been given to me. So I couldn't use that in a proportion to help me solve for anything. I'm going to do the same thing now for that medium triangle. And if I look at this medium triangle, I'm given the hypotenuse, it's 5.5. And I am given the short leg here of h, and the long leg here I don't really know. I know it's part of the overall distance of zx, but I don't know exactly what that is, so I do not have the long leg available to me. Okay, and then finally I'm going to do the same thing for the entire large triangle. And so we are given the hypotenuse, which is down on the bottom side, 6.3. We are given the short side over here, short leg over here, which is 3.1, and we also have the long leg here, which is 5.5. Okay, so the reason I'm having you write this out, or at least think through which values you have and which you don't, is because it's going to allow you to see which triangles should you match up to try to put in a proportion. Okay, so I look at the things that I have from both triangles. So I'd look at this and say, if I want to compare the small triangle to something, I need another triangle that has a hypotenuse and a long leg. So I could compare the small triangle and the large triangle using those values. I could also take a look at the medium triangle and say, well, I've got a hypotenuse there and a short leg there. What other triangles do I have with those things? Well, I'd have to compare it to the large triangle because it's also got the hypotenuse and short leg. You'll notice I couldn't compare the medium triangle to the small triangle because although it does have a hypotenuse, it doesn't have a short leg, so we'd be missing a value there. There's something that we couldn't fill in that position. Okay, so let's set up our proportion. We'll use what I've got circled in blue up here, so we'll use the small triangle and the large triangle, and within those triangles we'll use the hypotenuse and the long leg. Okay, so I'm just going to set up an equation or a proportion, and I will say that this is the small triangle on the top. This is going to be the large triangle on the bottom. This is going to be our hypotenuse, and this is going to be our long leg. Okay, so if I look at the small triangle hypotenuse, that would be this distance, yx, so I can fill in my 3.1. I don't have a whole lot of room, so I'm not going to put the meters in there. Typically you would. I'm going to look at the large triangle hypotenuse, and that's the entire bottom side, which is 6.3. Then I'd look at the small triangle long leg, which is YW. That's the variable that we're looking for. We're trying to find H, and so we wanted to have that as a part of our proportion, and I'm going to compare that then to the large triangle long leg, which is 5.5. And so I know that these two ratios that I've just written are indeed equal to one another. It is a proportion because these are similar right triangles. So at this point, all I really have to do is cross multiply, and I'm going to say that 3.1 times 5.5 is exactly the same as 6.3 times H, okay, this cross product. And when I do that multiplication, 5.5 times 3.1, I got 17.05 when I plug that into my calculator. Compare that to the 6.3H. And now I'd get H by itself by dividing away 6.3 on either side. And so that gives me a height of approximately 2.7. And the last thing I would do is look back up here and say, does this make sense based on the other values that are given to me that this would be about 2.7? I think it does. So that's how we'd actually set up those proportions and plug in specific values to find a missing length.